So here we are back in the ham shack, and we're going to be talking about ground again. Perennial favorite subject of every ham radio operator, ground. And in this case, we're going to look at the ground radials, radial and for an vertical monopole. This comes from standard work that's already been discussed elsewhere and is derived from Brown Lewis Epstein's seminal work on RF radiators at 3 megahertz. So I'm going to turn to my chalk and talk here because this is about ground and the radials, and I'm going to show you some alternatives to that massive investment in copper. We're going to trim it down here a little. So here you can see a rough approximation in this left half of a vertical antenna ground system consisting of 120 radials. Think of this being 60 of those radials, extending out all the way to the end. And I've discussed before, the radials are part of the returning the current back to the antenna radiation system. And all of these are radiators in themselves, but since this element is opposite this element, its radiation cancels. This works in the ground or elevated into the sky. If you're feeding the same current into this point and it's going out in all directions, their mirrors are going to cancel. But you might ask, well, what's going on this side? Well, on this side, I'm varying from the full length radial to the half length radial to provisionally a quarter length of the radial. And then going back to the full length, half, quarter, full, half, quarter, full, half, quarter. This is to conserve the effort that's required to build a ground system. And you might say, well, what's it doing? Yeah, let's turn to me. You might ask, well, what's this? What's the bottom line here? How does this improve my situation? Well, it takes a step back from the full improvement of the full 120 radials, if you ever went there in the first place. It has more to do with your investment in time and being able to accept some reduction of signal level. How much? I'd say in the tenths of a dB. We'll certainly lose more to other considerations than that, but let's return to this, my picture. The reason for this is that the ground current this is the densest portion, and in this region here, there's a considerable amount of current flowing in this region. And you'll notice that all of my radials in either this system or this system fully encompass those majority current loops. Of course, as the frequency varies, that consideration changes. But even out to this point, we're doing pretty good on recovering current and re-radiating it. So this allows us to, we just trim off the unneeded ends, so to speak. However, we leave longer paths out to accommodate the lower frequencies. If we want to consider alternatives to this ground, the typical ground system, we we switch to another. Okay, let's say this is my feed point. We still have the radial in that direction, in this direction, and in this direction. But instead, this is what's called a ground screen. And we'll consider that every crossing point is connected so that there's electrical continuity across all points, crossings, and provides a uniform ground structure. The spacing here that I've used in the past has been so 1/10 of a wavelength on the side. So this is roughly a quarter wavelength. This is roughly quarter wavelength as shown, plus or minus. Another substitute, well, you can do this. Let me go back to the shack. This ground screen can be accomplished through a number of methods. I've seen it done with chicken wire, hog wire. It's the quick way to lay it down. It doesn't guarantee that you're going to have electrical connections between all conductors, but the proximity of them and in a, well, somewhat conductive medium, earth, completes the current paths. More losses, of course, but it's better than it not being there at all. So that's another consideration. Generally, when you do this kind of construction, let's go back to the drawing. The feed point will have a higher density of grid. So something like that. And this, of course, mimics the earlier shortened radials that I'd offered you. So there we have ground. And it's not finished yet. I'm sure I have much more to say, and I'm going to say something almost immediately after this, but it's going to embrace other topics, antenna design and propagation both, and it's still about ground. So we'll move on to that next, but until then, 73s.